Today we're going to be starting on a series of tutorials about MATLAB programming. We're going to use some of the questions that I've had to solve in my university course, starting off with the most easy, as it helps us learn quite a lot of important methods in programming. This tutorial is going to be for complete beginners with never programmed before. If you'd programmed before, I imagine you'd be able to solve this in, I don't know, half an hour. It's not hard at all. Okay, so the problem here is on the screen. The university has a default pass mark of 40%. However, for this module, it's 70%. And so to convert your raw marks into the final module marks, they need some kind of algorithm that will do that for them. It's got some things at the bottom here, some conditions that it wants you to be able to do, and we'll go through them because again, there's some they're in there to either make your life easier than it needs to be, or to show that you can actually do more than the very minimum, and they'll be incredibly useful to use later on. So, for example, this last one, sort of add circular individual points. That will be quite important going forward. When you do sort of more advanced MATLAB stuff, you might want to highlight a certain point on the graph, not every single one. So let's begin. So first of all, what's it actually saying? So in this problem, the first 60 of the marks are halved, the next 10 are untouched, and then the rest are doubled. So as it said in here, 84. What happens to it? So that becomes 30. That becomes 10. That becomes 28. So plus the 68 off the top of my head. I hope that's right. Yes. There we are. So basically, we've got to write an algorithm that is gonna carry this out for us. So we don't have to. So you can just put in a mark, for example. Perhaps you deploy this in a system where you know their mark was, I don't know, 79. You put it in, it would calculate the final answer. But in this situation, it just wants us to do it in for sort of these these numbers of marks. Okay, so MATLAB's got some really cool ways of declaring variables. In other systems, declaring arrays they're pretty easy, but in MATLAB we can literally in not very many characters declare this variable. This array. We don't have to declare an array of 11 boxes and go 0, 10 to 100. What we can do is we can just create an array called raw marks equals 0. That's its starting point. The semicolon is then sort of an indicator, it's a breaker. The next is the step, so we're going to put 10, and then the final one is going to be 100, and semicolon to end the variable declaration. So what we've done here is we've declared a variable raw marks that is 0 to 10, 0 to 100, but with everyone being 10. So if we were to print this variable now, it would be 0 to 10, 20, 30, etc. You get it. Now we're obviously converting these marks into the final marks. We've got to have somewhere to save those final module marks, we'll call them. So another array, and it's got to have obviously the same number of boxes. It's got to correlate because every mark in here it's got to be outputted in something. So we're just going to put module marks here, and we'll just do for now we'll just do exactly the same. It's going to be equal. It doesn't matter because we're going to overwrite everything in there. Now you might notice here in the way I've declared these variables, the first word is lowercase, and then we capitalise the first letter of the second word. This is called camel text. It's really complex in programming. First of all, it's much easier than putting an underscore in. Well, I find it is, and you can't have space in variables in I think in any programming language. It's just clean. It's really good practice to use it. Some people use underscores. I've never have. You can if you want, but majority of programmers know we'll use this camel text. And what we've done here is we've declared basically integer arrays in MATLAB, Now, if we've just done, say, we'll call it, make another variable I, and we'll just say it's equal to 1. This is just an integer. That's all it is. There's nothing else to it. There's nothing. It's just a singular. And if we do I equals, and then these two quotation marks, and then go hello world, this is making I equal to a string. So the variable I now holds the data of hello world, whereas the raw marks holds the data of these 11 boxes, 0 to 100 and steps of 10. So these are different types of variables. I won't go into too much detail about what they are. If you're doing MatLab, I'm sure you're probably doing some kind of science-based degree. They're not very complicated, different types of variables. You can look them up. It will take 30 seconds. Integer is a whole number that you should know from maths. An array is just a group of them, or a list of them. You can have floats and doubles as well. Floats and doubles just have different numbers of decimal places on them. Strings are characters, and you can have character variables as well, which are singular characters, but you don't really need to sort of worry about them with MATLAB. That's more focused in sort of generic programming languages when you have to deal with stuff like that. So now we've got the basics of what we need. We need to sort of look at how would we go around doing this. How are we going to go about solving this problem? Well, what we've got to do is we've got to go through the array of raw marks, all 11 of them, 0 to 10, 0 to 100, sorry, and convert it into its corresponding exam mark. Well, how would you do that? So how would you go about every single one? Now, you could put in here a massive long script that goes, literally goes, I don't know, module mark 1. So let's go. Equals so equals, sorry, I was thinking about that. Module mark 1 equals raw marks 1 divided by 2, which it does. That's not wrong, but if we do this for every single one of them, it's going to be long, quite inefficient, because we're essentially writing the same bit of code over and over again for the first 3 anyway. First 6, sorry. Now, there's actually nothing in programming. It takes up more space, and we have these things I suppose called loops, and loops basically can run the same bit of code over and over again, for a condition. So in my case, we use a while loop. You can use for loops as well; they exist. But personally, I'm going to use while loop. It's just personal preference, but I know other people who answer this question used a for loop. Now, in some languages, I think MATLAB you can do it as well. You'd have a while loop, and the condition would be here. So we'll just put I less than 11 because that is going to be our condition. Less than or equal to 11. Sorry, I'll go into that in a minute. And then these brackets, MATLAB seems to be throwing an error, but in some programming languages you use these curly brackets to define statements, so ifs or whiles. But we're just going to use end in MATLAB because that's what it seems to like the most. Now, sorry, again, how we do everything in MATLAB. It's been a while since I've done it. No, I was throwing that error. Now, while I, it's throwing up this error here because we're saying while I is less than 11, but we haven't actually declared I. Now, with imaginary numbers, I is often used to represent something, represent square root minus 1. Now, in programming, I is almost always used to represent like a counter. So in a loop, it starts off as 0 or whatever, and it counts. It goes up, increments, and you use it to sort of make sure the loop only happens a certain number of times. It's really good practice just to always use it for that and not use it for anything else. Because if someone else is to read your code, they'll assume that. So in this case, we'll just start I equals 1. Lots of programming languages, the first box, or because if you think about a list, an array as a series of boxes with data in, we've got 11 in these arrays. lots of them start the first box being box 0. In MATLAB, it starts first box being box 1. So we're just going to say starting off at 1. So while I is less than 11. Now, if we just put some code in here that says, I don't know, print hello world, and we just ran that code, what it's going to do is it's just going to indefinitely run, because we've hard coded I is equal 1 here, but we're not actually making any changes to 1 in the loop. So you have any changes to I in the loop. So we have to make those changes to I in the loop, because otherwise this loop's always going to run. So we'll just, before we get on with any other code, we're going to say I equals I plus 1. And what this is saying now is we're redeclaring I, and it's the value of I at the beginning of the loop plus 1. So we run this loop, y is less than 11, okay, do xcode. I now equals I plus 1, so it's now going to be equal to 2, still less than 11, and so on. You get the idea. Okay, so what we actually got to do in this loop? Well, we've got to go through this array here, raw marks, and we've got to convert it into module marks. Now, for every, so we might want to start off with raw marks. Now, to choose which box we're picking from the array, which box we want to deal with, as I said, think of an array as a series of boxes. We're just dealing with one-dimensional arrays at the moment, so it's quite simple. It's literally just a row of boxes, and in that first, we can't deal with the whole array at once, as you know, they're all independent numbers. We can't take all 11 of them and just do something. So what you can, but we'll get into that in another time. So what we want to do is we want to pick an individual box that we want to do something with. So, well, at first we want to start with box 1, don't we? So we want to start with the first box in the list. But if we do that, if we write box 1, then that every time that's going to go to box 1. What we really want to do to be efficient is we want to use I, because what this means is every time this loop runs, it's going to move to the next piece or next box in the array of raw marks, because I is going to go up every time. So the first time it's going to deal with the first box, and then it's going to move on to the second box, then the third, so on. And that way we can minimize the amount of code we want to run. Now, in this case, we want the first 6 marks, we want to half them. We want to turn anything up to 60 needs to be half its original value. So that's a condition, because if it is above 60 or above 60, then we don't want to deal with it. We don't want to do what we're about to do to it. So we need to tell the program to do that. So we start off with another statement called if statement. It's really as simple as, if this is the case, do something. So if a condition, we need a condition here. So if raw marks, and again we're going to use I, because that means it changes every time, is less than or equal to 60, because remember it's got to include 60. You can put less than 61, but personally I think it needs to just write less than or equals. This here is how in computer language less than or equals 60. And then we're going to end, because we want to run this piece of code here. So what do we want to do if that's the case? Well, if so, we want module marks. So let's make this a bit neater, a bit clearer. Module marks I to be equal raw marks I divided by 2. So if you see here, so if this is, say, this box 2 is going to be 10, not 0, not 20, sorry, it's going to be 10. So it's going to come in here and it's going to go raw marks are box 2, well, that's equal to 10. Is that less than or equal to 60? Yes, it is. So we're going to do module marks I, so the corresponding box, so the second box in here, which happens to be 20 because of the way we've declared the variable, but module marks I is now equal to raw marks I divided by 2, so it's now going to be equal to 5. So that's all we want, and that's going to do that for all of them that are less than 60. Now, let's move on to what happens if they're above 60. Well, if they're above 60, but less than 70, remember, we want to do something. Now this is another if. Now you can do end here and then do an if, but that's a bit messy because you end up having lots of statements. So there's what we call an else statement in programming. So we can have else do something. Basically, if this isn't true, if this if statement isn't true, do something else. However, because we have a condition in here too, where if it's over than 60 and less than 71, I should say, then leave it as it is. There is also an if statement in there too. And going forward, this isn't the last in the line. We've got something coming after this. We have if it's above 70, we want to double it. So we can't just leave this as it is. There's going to be more statements coming through. So we want to have what's called an else if statement, which is literally else if. Again, this is another really common. This whole structure here is incredibly common in every programming language has every high level object oriented program will have this, as well as while loops. So else if raw marks, because remember we want to only deal with the certain boxes happening in this cycle of the loop, is now if it's less than or equal to 60, it's going to perform this action. So we don't need to specify over or equal to 70 because we've already done that in this here. Basically, if it's over or equal. If it's over 60, it's just not going to do this. It's going to skip this whole section of code and just go straight to this one. So we don't need to specify that. We just need to go less than or equal to 70. Now it's going to perform this code. And we're just going to put module marks I, because remember we're dealing with that box in the array, equals raw marks I, because what it's saying is it's going to be exactly the same as the raw marks. Now, that isn't really true. What we're saying is we don't want to change those 10 marks. But if you remember, this raw mark section here, let's say 75, not 75, let's say it's 65. Well, module marks I equals raw marks I. That means they're both going to be equal to 65, but that isn't correct because it's not taking into account the first 60 marks needs to be divided by 2. So what can we do about this? Now, we know because we've got to here that the first 60 marks are already going to be halved in this section here. So, and we know it's above 60. So we can, because the first 60 are halved and we know the first 60 are going to be 30, what we can do is we can just subtract 30 from raw marks here. Because if we come through here and this is 65, now if we take the first 60 out of that 65 divided by 2, it's going to be 30, and the next 5 is left unchanged. So if we just if you add that 5 to that 30, it's 35. So if you just subtract 30 here from the 65, it's going to be 35. And it works the same for 69 as well. The first 60 marks are going to be halved, which is going to be 30, and the next 9 are going to be left the same. So we just again subtract 30. So module marks is going to be equal to raw marks I minus 30. Now that's that. Now we're just on to the last part of the code. What do we need to do for every other raw mark? Because we've dealt with the first 60, dealt with the next 10. There's only another 20 left. What do we want to do with all of those? So because this is going to apply to all other marks above 70, there's no other statements coming. We can literally just put an else. Else, if any of this isn't true, do this. So what we need to do is we need to go module marks. Again, we're going to be looking at just the individual box corresponding. Remember, these all correspond. So raw marks 1, we want module marks 1 to be corresponding to raw marks 1. So module marks I equals something. Now, in the question, we know that the first 10, the next 20 are doubled. So you could put raw marks times 2, but remember we don't want that to happen. We only want the final 20 to be doubled. So we need to subtract the first 80, or I'm pretty sure it's 79, because all marks above 70. Yeah, sorry, the next I've been saying 20 the whole time, but I meant 30, sorry. So we want the next 30 to be doubled. So we know, what we do know is that anything that comes down this side is going to be above 70, or because this is less than or equal to 71, 70, so anything in that bracket is going to have all this code here applied to it. So what happens if 71 comes along? The final mark we want to come out is 42, because the first 60 are halved, next 10 left to change, left the same, and that last one is doubled. Now, if you look at that, every other mark coming after this, the base one is going to be 40. So let's just start with that, 40 plus something. And what it's going to be is it's going to be raw marks I minus 70, makes it a little bit neater, times 2. And we're just going to put these in brackets to make sure it all applies in the right order. There we go. So it's going to be 40, because anything that comes past here, this is going to be 40. It's going to be 40 plus the remaining value of raw marks. So if it's 71, we want to get rid of that first 70 times by 2. Now this is going to apply. This is going to go through raw marks, every single one of raw marks, because there's 11 boxes. Change them all to the corresponding module marks. And now, if we just to prove this, we'll get the console. We're just going to run a first test of the code. We're just going to literally get the console to display the array module marks. Now this little command here, dis, that means display, and what it's going to do is down here in the command window is it's just going to print out whatever data is in here. You can get it to display text, so you can put here in speech marks it to display text. But because we're putting 2 bits of data in here, you need to put a plus between them. So we want to display this text and we want to display this array. So if I run this bit of code now, there's no add to path, so that's the save thing. As you can see here, what it's done is it's output them, and it tells you columns, the starting column, so the first column is what it is. The first column, the array. When I've been calling them boxes, it calls them columns. So 0 is correct, 5, that'll be 10, 20, 30, 40, and see, it all starts to make sense up until 60 here. Now 70 is 40, right? 80 is 60. It's all looking good. And again, last one, 100, brilliant. So we know that the module marks do go 0 to 100, and from what we can tell, they all look correct. So that's great. So now we've done our debugging. We know that our loop here is working. So now the last thing it wants us to do is it wants us to plot on the y-axis the one of the like final mark, and on the x-axis the module mark. I have used opposite terminology to him here. So when he says module mark, he is referring to like the mark that it puts in. So what I've called raw marks. Okay, so what we need to do here is we need to just plot this. So we want to plot. Now, when you plot something, you put in the first thing you put is the x data. So we want raw marks on the x-axis, and then on the y-axis we put a comma to separate them. On the y-axis we want module marks. Let's see if this has worked. Shall we run it again? It's going to be embarrassing if it hasn't. There we go. Look, there we are. Brilliant. Exactly as we wanted. He said plot as a black continuous line. So what we want to look up are the MatLab line codes. I should know these off the top of my head, but I don't. So So these here, any Google will come up with these. These are what you then put next to signify how you want that line to appear. So solid, dashed. Default is always solid, and then you can change to these two. So these can signify the marker of every single point. We're just going to leave that. We want to change it to a black line, which means we need to use the letter K. So in here, after the module mark, put again a comma to signify we're asking for something else. And the third one is always going to be the line style. So we just put K here, and that will change the color. If we want to change anything else, we put something else in there, but we just want to change the color. So that's there now. If you had anything else to put in here, you just put it again in the same quotations. So say we wanted a dashed line or a dotted line, we just put that, and with circle points we put that. And then if we run that, see how it's dashed line now and circles at every point. But we don't want that, so we're just gonna remove that. Now he's also said in his question that he wants us to put some suitable axis labels on the plot or graph, and then circle certain points. There's a number of ways to do this. I did speak to him about it. Not that it really matters to you, but he doesn't really care. So what we're going to do is just do another line here, another plot. Now, because we're plotting two graphs here, if we want them to stay on the same one, we need to use a command called hold and then on in MATLAB. What this is saying is this is the command hold, as in keep this graph here, and then do this one, and we want it on. So we now need some data to put in here. So we'll just create some new arrays. So we'll call them special raw, and we're going to say which ones did he want? He wanted 46, 66, and 86, and we want to put 46, 66, and 86 in that array. We use a square brackets to signify the data. We're going to put data in this array. 46 is the first one. Space to say this is our new data point. 66, 86. Just end it with a semicolon again, and there we are. It's happy. Now we want special module, and 46. Half 46 is 23. Half 60 is 30. Next day the same, so it's 36. And then 86. Well, we want the third. That's going to be 40 plus 16 times 2. So 16 times 2 is 32. So 72 there. And then that again. And we want to plot special raw against special module. And he said he wants red circles. And that is that. So RO, we use O, not 0. And if I should run this now, there you go. There you see they're all circled, those two ones, and they're on that line too. Okay, so now we need to annotate the graphs and title. Very simple. You literally just put title, what you want the title to be. In brackets, again, it's text, so you need to put it in apostrophes. And the title is going to be raw marks versus module marks. Now, what label do we want on the x-axis? Super simple. X label. Again, like the title, what we're putting in is in what we put in the x label. It needs to be in brackets. It's text. We need to put in apostrophes. The reason you use apostrophes inside these brackets, it may seem really pointless, but if you just put the brackets, because the brackets signify to the command what you want it to be. If you just put text in the bracket, it will go, it will assume that's a variable name, and then go look for that variable and throw out an error if it can't find it. You then put apostrophes in to say it's not a variable, it's raw text. This way, you could have a really modular code so you could use it to, you could basically write some program that got a bunch of data, user inputted data, what that data is called and what it means, and then it can output it as a graph and using that kind of stuff. So therefore, the X label and Y label could all be different. But in this case, we're going to put plain text, so we want it in apostrophes in brackets. So X label is just going to be raw marks. Y label, again, really simple. Now, if we run this code, there you go. Got the X label, the Y label, the title, and the graph as so. So hopefully at the end of this tutorial now you feel a bit more confident with loops and the fact they need conditions, if statements, they need conditions, what all those things are, and the declaration of variables. Going forward we'll look at functions and again look at while statements or while loops and things, and just sort of make sure we can do a bit of a better job. We might even look at some other sort of features in MatLab that are commonly used. Thank you for watching. I hope you enjoyed. Goodbye.